All right, so now what we're going to do is we're going to create linear models from numerical data. So we're going to have a table of data and we're going to create a linear model. So data can be perfectly linear. Now real world data usually is perfectly linear, or we're just going to have data that is overall a linear in nature. Okay, so so perfectly linear set of data would look something like that, and our real world data, it might be kind of like that. And so we fit a line to it, the best fit line that goes through those points, and then that will give us a model for that set of data. Now the numerical data plotted on an XY coordinate system to obtain a scatter plot to determine overall shape. So that's what we need to do. So we'll plot the data and we'll see, okay, what does it look like? And so, yeah, that looks pretty linear, and then you can do your linear fit. And so linear equations then are modeled from the data to answer any questions posed about that data set. And I was talking earlier about extrapolation, and so this is kind of where this comes into play. Interpolation versus extrapolation. They're going to both be used to estimate hypothetical values for a variable based on observations that are, other ways, maybe like I was saying, maybe we wanted to look at what happened at 3,000 or what happened at 1,000. So interpolation, that's using a model to calculate an output value that is within the interval of the input data used to obtain the model. So it's kind of within that, I think it was 2 less than x less than 2,400 or something. So that 1,000 was within that interval that we created the model. Now, extrapolation, using a model to calculate an output value that is outside of the interval of the input data used to obtain the model. So, when we use that 3,000, that's way out here. That's not within the model range, and so we're extrapolating data out here. So we're totally assuming that everything continues along the same way, and that's how we can say, yeah, we're extrapolating, and we're saying that's the case. Now, if it really is that way, we don't know for sure. That's the problem. All right, so when we're doing graphs, sometimes what we have to do is something called data aligning. And so basically we're going to renumber the input data to reduce the magnitude of some of the coefficients. And so what happens is if we're given the years 2005 through 2010, we could realign these numbers to 0 through 5. So we'll say 0 is 2005, and then 2006, 2007, 2008, 2009, oops, I'm starting to write numbers I'm saying. So 7, 8, and then 9, and then 10. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep, there we go. I can do it, but not write it and do it at the same time. All right, so what we're going to do is if we use these big numbers, we're going to get big numbers for our slope and our intercept and things. It's going to look really, really strange. And so what we're going to do is we're going to realign our data. Now note the slope of the line doesn't change when realigning. It just shifts the data numbers horizontally, and it's usually to the left because if you think about it, if we're way out here at 2005 and now we've shifted that down here to 0, that is a big shift to the left. Okay, and so we're also have a different y-intercept, and so that's going to give us, a different y-intercept. Now our slope again, it doesn't change, so that data is still going to maybe go something like this, but we've gone from saying that here is 2005 to saying, oh well, now we're shifting everything, and now it's going to be at 0. So we've shifted everything over here to 0, and so it's going to be different. And so what we're going to do is an example here. And because this is supposed to be a class where we learn different kinds of technology, we're going to work with this both with a calculator as well as Excel. All right, so pampered pets. So the pet industry is big business in the US. The amount spent yearly on pets continues to increase. Now, based on scatter plot of the data in the table, why is a linear model appropriate? Well, we're going to have to figure out if it is appropriate or not. And so that means we're going to have to plot that. Then we're going to align the data so that 1994 is the year 0. Write a linear model for the amount spent each year on American pets. Use the model to estimate the amount that will be spent on pets in 2013 and what assumptions must be made for this to be considered a valid argument. So first, let's realign the data. So what that's going to be is we're going to say, well, now 1994 is really 0. 96 is 1. 98, well, actually, that's 2, sorry. 2 years in there. And then this is going to be 4. and then 3 more after that, 7, and then 8, and then 9, and then 10, 11, 12, 13, 14. Okay, so 14 years after 1994 is that, so that looks like I must have done it. Started off a little bit wrong because it went from 4 to 6, so I forgot that's 2 years, not 1. So you have to be careful of that because sometimes you'll be doing 1 point jumps, sometimes you'll do 2, 2, and then 3, and so you really have to pay attention when you're realigning your data, because if you just go 0, 1, 2, 3, 4, 5, 6, you know, the original data might look something like that, but then all of a sudden when you do it, it might go and jump all around and it won't have the right data because you have the wrong x intervals. So what I'm going to do now is switch over to Calculator and Excel. All right, so let's go to a calculator first. Now, what we need to do, actually, what I need to do is first, I need to figure out what we're going from 0 to 14, so our X can be 0 to 14, and our dollars can be 0 to, say, 50. So let's do that first. So our window, X is going to be 0 to 14, so let's do 15. We can do by, I don't know, 2s or 3s. Let's do 3s. Sorry, is going to be, let's start at 0 and let's go up to 50. We could start it a little bit higher, but we can just do that, and then we'll go by 10s. And so now what we need to do is put our data in. Now, because there's so much data, I went ahead and typed it in early so we wouldn't have to worry about it. And so I have an L1, I have my X's, L2, I have my Y's. And so now what we need to do is see, does it look linear? Well, what we now need to do is we need to go to second stat plot, and we need to turn on our plot because we have it turned off now. So we need to turn it on. And so we hit enter, then hit enter again. Now it should be on. So now we can go to graph, and that's the graph of that data we just looked at. Now, does that look linear? Yeah, it looks pretty linear. And so it does seem to be a model that could be used for linear. Now let's go ahead and figure out our calculation for the linear equation. So we go over to calc and we go down to linear regression. So that's number 4. Our x is in 1, y is in 2. And so now we can just enter, 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 enter. And this gives us our function for the slope and our intercept. And I think this is why we use A for our book, because it's kind of really tied into the calculator. And since they use A in a calculator, that's why we're using A for the book. Okay. Now, so we have those two things. Now we see our R value is 0.99, so that's really pretty good. The closer to 1 it is, the better. And so that looks like a good number. Now let's go ahead. I'm going to write down our values here so I know what they are when I come back to the screen. So we have 1.855341506, and that's our A, and our B is 16.2017531. So those values we'll be needing in a little bit. And let's see, now we've got our graph, we've got the equation. So now let's go over to Excel. And again, I've typed them in just because I want to save time on typing and not have any mistakes on typing errors. And now we're going to graph it to see what it looks like. So we highlight it, we're going to insert, and we want to scatter plot. And yeah, that looks about the same as what we just had on our calculator. So that's how we get the scatter plot. Now we want to add a trend line, which is going to give us our equation of our line. So we right click on that, add trend line, and we have that. And now we go over here and say, well, let's also make sure first it says linear, and let's display the equation on the chart and go ahead and we can put our R squared. That's fine too. Doesn't matter. And so now we have the same basic thing. The other one we had, 1.855341506, and this rounds it to 1.8553. Okay, and then we had the other one 16.2017531, and it rounds it to 16.202. So both of them give us roughly the same values. One of them give us a few more decimal places, which is useful because when we're actually going to calculate, numbers in that range, say maybe we wanted to know what is 5, we could plug that 5 into our equation and come up with a value for our output, and it will see where it would land on that line. All right, so now let's go back and see what we're supposed to do now. So we've done that. We've saw it's a linear model by plotting it in both the calculator and Excel. And we've aligned the data so that the year was 0. And then now write a linear model for the amount spent each year on American Pets. Okay, so that's what we need to do here, or let's do it over here so we can have big space. And so what we're writing on pet, I don't know, let's call it P of X maybe. P of X is equal to, and now our slope was 1.855. And if we want to go 3 times X plus the 16.201, and then that would be an 8. Okay, so that would be our linear model. And again, it doesn't say, what decimal place to round it to. So, if we did it based on this, we'd only have one decimal place, but I think that's not enough to do it justice here. So we'll go to 4 and we'll call it good for that. Now, we're going to use the model to estimate the amount that will be spent on pets in 2013 and what assumptions must be made for this to be considered a valid estimate. Well, 2013, that's beyond our data. So this is going to be an extrapolation. Because it's an extrapolation, we're going to have to assume the model continues on in the same fashion past 2008. If it doesn't go on like that past 2008, that's going to be the issue that we're going to run into, that we don't know if it's true or not. So that's our assumption. So now let's go back here. And now what we're going to do is we're going to plug in to that, what was it, 2013? Yes, so it's going to be another 5 years, so 19 years. So X is going to be 19. So we'll have 1.855341506 times 19, and then plus 16.20175,131. And again, I'm using all the decimal places that our calculator gave us just to be the most exact as possible. And at this point now, I can round. Now, what would have happened if I would have not used all those decimal places? I don't know. Let's see. Now, see, sometimes what happens is if you're doing certain things, it might actually cause the value. Maybe if you're working in millions of dollars and you have an interest and you round it, you're going to be off by hundreds of thousands of dollars. And so, you wouldn't want to have that. So if we round to 2 decimal places and call that as 6, and then do that, it's a little different. So, let's use that whole thing. And so that says we're going to have 51.45 is what I'm going to round it to. Now let's go back to our thing here. How much will be spent on pets in 2013? All right, so this is in billions of dollars. So I'm going to say it was $51.45 in billions spent on, I think it was pets, just pets and in general. It didn't have any kind of certain pets. So pets in 2013. And this is, again, it's an extrapolation. So we're just betting on the fact that the model continues on as it was from time 1994 to the time 2008. All right, so I'll pause there.